Hi, in this section we are going to talk about esterification, which is part of our organic chemistry reactions that we need to know. Now, esterification is an important process because it produces for us esters. Esters are famous for their pleasant smells, and therefore they have a wide range of industrial uses, but mainly they are used for the production of perfumes and artificial food colorings and scents that we have, which are smells. So we are able to definitely use esters in the practical world, and therefore it's part of our organic reactions that we need to know very well. Now, esterification is the reaction of an alcohol with a carboxylic acid to produce an ester with water as a byproduct. Now, what do we mean? We mean when an alcohol reacts with a carboxylic acid, the products that are then formed are an ester, which is the main organic part that we are looking for. However, water is also formed, and water is actually inorganic, as we had explained in the introduction to organic chemistry, that when we talk about organic chemistry, the organic part, or what makes compounds organic, is not what we have in the usual use of English, where we just say when there's no additives, it's naturally appearing or whatever. No, here it's about carbon needs to be the central atom. So water is not having any carbon, therefore carbon is not a central atom for it. It falls under inorganic. And some questions do specifically ask you, what is the inorganic product during esterification? Then you should know that they're referring to the water part or the H2O part. Then, this process, for it to properly occur, we need a catalyst. That catalyst is called sulfuric acid. It also needs to be concentrated, so the highly concentrated sulfuric acid is able to act as a catalyst for this particular reaction. We can have others, but this is the most important one that we usually refer to. That's organic chemistry. Now we are going to look at how to identify the esters and some of the naming parts of the esters, how important it is to know the name. And given the name of an ester, you can always tell the alcohol that reacted as well as the acid that reacted. Also meaning, given the alcohol and the acid that react, you will be able to name the ester from that. So you must pay careful attention to that. We are first going to look at the functional group. How do we identify that the compound we are looking at is definitely an ester? So esters have to have what we call a carbonyl group, which means that they are going to have a C, OC, with a double bonded O to one of the C's. So remember, we're using an alcohol which must have at least one carbon, and we're using an acid which also must have at least one carbon. This means that when we mix the two together, we will have at least two carbons present. So definitely we are going to have esters with at least two carbons. Now, the molecular formula or general molecular formula of esters is that the number of carbons you have, you will have double the number in hydrogens, as well as two oxygens, of course, because of the O and another O that should be there to make the ester. Now, if we take closer attention or pay closer attention to it, you'll notice that this is exactly the formula for carboxylic acids. The only difference is that with carboxylic acids, the double O's are at the very end or are at the terminal carbon. You can take it as the start or end, so we say terminal carbon for the compound for esters, for acids. So they are therefore called functional isomers because it means that they are the same, they have the same molecular formula, but they are having different molecular structures, especially because of the positioning of the double O's. Is that okay? So now let's go back and check the naming. The naming, we will have an alcohol that will get an IL part, so that will be our alkyl section, and then the acid part will get the NO8 to the name of the ester. So the name of an ester has two components to it. So let's look at an example because we understand it better when we do an example. Now, let's say that ethanol, which is the alcohol, is reacting with propanoic acid. So this is ethanol, which has two carbons, reacts with propanoic acid, which has 1, 2, 3 carbons. Therefore, the product that would be formed is ethyl, coming from the alcohol part, propanoate. So the propanoate comes from the propanoic. So just by looking at this, we know that the alcohol was ethanol, and then propanoic acid was also used for this compound. So that's what we have, and therefore there's also the water on the side. So now, This is the molecular structures. Here we have the molecular structure of ethanol, which is an alcohol with 2 carbons and the OH or hydroxide group. And then here we have the acid. So we have the 1, 2, 3 carbons with the carboxyl group to make it the acid. But now here we have the ester, which has the 1, 2 carbons, separation O. Then we have the double bonded O on the acid side because it came with the acid. And then the acid side has 1, 2, 3 carbons, which again tells us propanoic acid was used, ethanol was also used. Of course, this is not balanced. We would need to add the H2O to this compound in order to make it properly balanced. It's quite easier to do balancing in this section of organic chemistry. There's not much challenges there. So that's what we have for esters. And esterification, remember, esterification is the produce of esters from alcohols and carboxylic acid. The catalyst used is concentrated sulfuric acid in order to speed up the reaction and ensure it occurs properly. And also we have the issue of the products formed. One is organic, which is the ester with